So in this part we are going to see different types of chemical equations or different categories of chemical reactions. There are 5 basic categories, plus we are going to see some additional subcategories, you can say. But what are the 5 different categories we are going to see? The first one is called as the combination reaction. Now as you can see here, combination is basically like A plus B gives you AB. We'll see this in more detail. It is when the two substances basically combine. Almost or exactly opposite of that is called as decomposition reaction, wherein one substance splits and forms simpler substances. Then the third category we are going to see is displacement reaction. Displacement reaction is the one in which a more stronger or more reactive element is going to replace less reactive element, which we'll see in detail again. Next category is called as the double displacement reaction, which is like the partner exchange reaction. And the last category is redox reaction. So these are the 5. Now redox reaction includes exchange or gaining and losing oxygen and hydrogen, which we'll see. These are the 5 different categories of main categories of reactions that we are going to see. Apart from that, as I said, we are going to see the subcategories. So let's start with each one of these separately. So the first one we are going to see is combination reaction. So what do you mean by a combination reaction? As I told you earlier, a combination reaction is the one in which 2 or more reactants combine and they form a single substance. Like here I've shown A plus B forms AB. So there are many examples that you can take in this category. Simple examples like C plus O2 gives CO2, or H plus O2 gives H2O. All these are combination reactions wherein only one product is formed during the reaction. Now here we have to take 2 important examples. One is burning of magnesium ribbon, and the second is reaction between calcium oxide and water. So this experiment of burning magnesium ribbon will be done in the laboratory. It's a very easy experiment. Basically you have to take magnesium ribbon, and before burning this magnesium ribbon you actually rub it with sandpaper. Now why do we rub it with sandpaper is we have to clean it before we actually burn it. What happens is magnesium reacts with whatever is in the surroundings. Like for example, there is oxygen surrounding or in the atmosphere, there is carbon dioxide. So magnesium can react with oxygen, magnesium can react with carbon dioxide and form a protective layer on its surface. So before burning magnesium oxide, we have to actually clean the magnesium ribbon. So we rub it with sandpaper so that we remove the protective oxide layer of magnesium oxide. Remember that it can react both with oxygen and carbon dioxide, but we can write the answer as to remove the protective layer of magnesium oxide. If it is asked why do we rub magnesium ribbon before burning it, why do we rub it with sandpaper? Now, so when you burn magnesium ribbon, you're going to see that magnesium ribbon is going to combine with oxygen and give you a dazzling white flame, and with this white flame you are going to get grayish color magnesium oxide. So basically when you burn it, it's going to combine with oxygen and give you MgO, which is magnesium oxide. So this is a simple combination reaction. Mg plus O2 gives you MgO. Also, in the other example that we are going to see here, we can see that we have taken calcium oxide, and this calcium oxide is mixed in water. Now calcium oxide is called as, commonly it is called as quicklime. And when this quicklime reacts with water, it simply forms calcium hydroxide. Calcium hydroxide is commonly called slaked lime. commonly called as slate lime. So you have to remember these names. Quicklime and slate lime could be asked for MCQs and such questions. So this is also a combination reaction wherein you can see that two reactants are combining to form a single product. In both these reactions, you will notice one more thing, that heat is released. Heat is released. First reaction, it is very easy to understand because we are burning magnesium ribbon, so you will see the heat being released. In the second reaction of calcium oxide with water, if you touch the beaker from outside, you will feel that the beaker is warm, and that suggests that the heat is being released during this chemical reaction. So these type of reactions wherein heat is released are also called exothermic reaction. Exo means to give out, and thermal means heat, as you know. So in this particular reaction, heat is released. So both these reactions can be called as exothermic reaction. Remember, most combination reactions are exothermic in nature. Now let's have a look at some of the examples of exothermic reactions. So here you can see I have shown methane being burnt, and burning or combustion is a good example of any exothermic process. So methane, when it burns, it produces carbon dioxide, water and heat. So it is a good example of exothermic reaction. Respiration is another good example of exothermic process, as respiration releases energy in the mitochondria of the cell, as you have learned in 9th standard. So whenever energy is released in any process, we can call it as exothermic. So respiration is a good example of a natural exothermic process. Another example we can take of a natural exothermic process is decomposition of natural substances. Decomposition of natural substances, like say for example any vegetable matter or kitchen waste, when it gets decomposed, it releases heat when it is being decomposed. So this is also a natural exothermic process. So again, these questions could be asked in MCQs, like for example, name some natural exothermic processes. You can say respiration is one, decomposition is another example. One more thing which could be asked with respect to combination reaction is uses of quicklime. So quicklime, remember, is used to whitewash the walls. Whitewashing the walls before painting your walls, normally they are whitewashed. That means they are painted with a white coat, and that is usually quicklime mixed with water, that is slate lime. And also quicklime is used in cement industries. So these are some of the uses of quicklime which you might want to remember. So this is what you need to remember about the combination reaction, as well as a subcategory, that is exothermic reactions. The next category of reaction is called decomposition reaction. Now decomposition reaction is the one in which one reactant, which might be a complex reactant, splits to form two or more simpler products. Now there are different ways in which you can decompose, or in which you can break down any substance. So for example, we can use heat to break down any substance, or we can use electricity to break down any substance, or we can use maybe sunlight to break down any substance. So based on what form of energy is used to break down any substance, we can categorize decomposition reactions into different categories. So first of those three categories is called thermal decomposition, wherein we use heat to break down any substance into simpler products. So there are three important examples which you need to remember. I have mentioned two here. I'll also tell you what is the third one. The first one is heating of ferrous sulfate crystals or ferrous sulfate salt. Now ferrous sulfate is green in color. Ferrous sulfate is green in color. When you heat ferrous sulfate, it will start decomposing. How will I notice this? I'll notice this because there'll be a color change. So from greenish color, you will start getting reddish brown color in the test tube. Now this is due to the formation of this substance called as ferric oxide. Ferric oxide is brown, so the color will change from green to brown. Also, you will see that there are some gases released. Now these are colorless gases, so you won't see these gases, but you'll be able to smell these gases. You'll get smell of burning sulfur, or what is also called as rotten egg smell, and that smell will be because of these two gases being released, that is sulfur dioxide and sulfur trioxide. So this is how ferrous sulfate breaks down or decomposes to form ferric oxide, sulfur dioxide and sulfur trioxide. Two things you have to remember: color changes from green to brown, and also the smell of burning sulfur released, or rotten egg smell released. The second example is heating of lead nitrate. When you heat lead nitrate, which is a colorless, or you can say slightly white powder, you'll get three products: lead oxide, nitrogen dioxide and oxygen. The brown fumes that you see here in the test tube, these brown fumes are of this gas nitrogen dioxide being released during this heating process. So this is the main clue that you will get when lead nitrate is being heated. You will see this brown colored gas being released, and that will be of nitrogen dioxide. The yellow residue that you will get will be of lead oxide. So this is another example of heating or thermal decomposition, wherein a substance is heated and it starts splitting into simpler substances. One more example which you might want to remember is heating of calcium carbonate. Calcium carbonate formula is CaCO3. When you heat calcium carbonate, let me do that right. When you heat calcium carbonate, you get calcium oxide and carbon dioxide. So these are the three important examples you might want to remember when it comes to thermal decomposition process. The other two categories are photochemical or photolytic decomposition, photochemical, and electrolytic decomposition. Electrolytic decomposition. So here in the photochemical category, I have given an example wherein if I place silver chloride in a plate or a dish and expose it to sunlight, in presence of sunlight, silver chloride splits into metallic silver and chlorine gas. Chlorine is released in the form of a gas. So the color changes from white powder and it turns gray because of the formation of metallic silver. So clearly you can see on exposure to sunlight, it decomposes to form silver and chlorine. Now another example we can take is silver bromide, that is AgBr. Silver bromide also, when exposed to sunlight, it is going to produce metallic silver and bromine gas. So this is an example of photochemical decomposition process. So both these chemicals, like silver chloride and silver bromide, they have to be stored in dark bottles, because if you expose them to sunlight, they are just simply they'll just simply decompose into their respective products. Also remember that these substances were used in black and white photography. The third category of decomposition reaction is electrolytic decomposition reaction, and basically it is an electrolysis process. So the example given here is splitting of water into hydrogen and oxygen by passing electricity through water. So here I have shown an electrolytic setup, as you can see in the slide. So what we can do is we can take a beaker and put two electrodes, metal rods, which are then covered with inverted test tubes. As you can see here, there are two test tubes, and both these electrodes are connected to the battery. One which is connected to the positive battery is anode, one which is connected to the negative terminal of the battery is cathode. Also, because we take distilled water in the beaker, distilled water does not contain ions, so it is not a very good conductor of electricity. So we add few drops of acids to increase the electrical conductivity of distilled water. Like sulfuric acid, we can add few drops to increase the electrical conductivity. Once you pass electricity through this setup, you'll observe that water splits or starts splitting into hydrogen and oxygen. How will I be able to know this? Is I'll start seeing bubbles, as you can see in the diagram, and both these gases, hydrogen and oxygen, will actually start collecting in these test tubes. Now oxygen will be released at anode, whereas hydrogen will be released at cathode during this particular reaction, and both these gases will start collecting in the test tube. As the gases are collected into the test tube, the water will be pushed down, so the level of water in the test tube will start decreasing. That's how you know that the gases are being collected. But you'll also notice that the amount of hydrogen is twice as big as oxygen that is being collected during this reaction. The simple reason is the amount of hydrogen to oxygen released when the water splits is 2:1. As you can see in the formula of water is H2O. So that means for every one oxygen there are two hydrogen atoms being released. So the ratio is 2:1. Hydrogen to oxygen ratio is 2:1, and hence you will see that when you split water, you will get 2 volumes of hydrogen for every 1 volume of oxygen. This is one more thing that you need to remember. Now all these equations or reactions that we saw, which are decomposition basically, all of them required energy. They absorbed energy, which is exactly opposite to what happened during the combination reaction. And these type of reactions where energy is absorbed to break the bonds, they are called as endothermic reactions, which are opposite to exothermic. So again, endothermic reactions are those which absorb energy during the reaction. And remember that decomposition reactions are endothermic reactions. So this is one more subcategory that you need to know. Next category of reaction is called displacement reaction. So what is the definition of displacement reaction? A displacement reaction is a reaction in which a more reactive element, like iron in this case, displaces or replaces a less reactive element, like copper in this case, which is less reactive than iron, from its salt solution. It takes its place and forms a new compound. Like for example, iron kicks out copper from its place and takes its place to form ferrous sulfate, and copper is kicked out, as you can see in this particular reaction. So the reaction is Fe, which is iron, plus copper sulfate CuSO4 gives FeSO4 plus Cu. So it's like a boxing match wherein a more stronger boxer or powerful boxer is kicking the weaker boxer out, and taking its place. So that's how the reaction occurs. It's a very simple reaction. What if I do it reverse? What if I take ferrous sulfate and add copper to it? There won't be any reaction in that case, because copper will not be able to displace iron from ferrous sulfate. Okay, so you have to know which elements are more reactive and which elements are less reactive, which can be known by studying what is called as reactivity series, which we'll see in metals and non-metals chapter. or I'll make another video on reactivity series and upload it so that you will know what is a reactivity series. Now, you should know a simple experiment here. In this case, what is done is we take copper sulfate in a test tube, which is blue color, and drop an iron nail in this copper sulfate solution. We have to wait for some time, maybe 20 minutes, half an hour. After some time, you'll observe that the color of copper sulfate will start fading first, and then it will slowly start becoming greenish because of the formation of ferrous sulfate. So what iron is doing here is iron is slowly replacing copper from copper sulfate to form ferrous sulfate. So the color change will be from blue to greenish color. Also, you will see that because the copper is being displaced, kicked out from its place, it has no place to go, so it starts depositing onto the iron nail, and iron nail will have this blue coating on it. So this shows that the displaced copper has been deposited onto the iron nail. So this is a simple displacement reaction, the reaction in which more reactive element replaces or displaces less reactive element from its salt solution. Next type of chemical reaction is called as double displacement reaction. Double displacement reaction can be easily remembered as partner exchange reaction. For example, here I have given a simple example to understand. AB reacts with CD. So when they react, they are going to exchange the partners with each other. For example, A is going to exchange its partner and combine with D, whereas C is going to exchange its partner with D and and combine with B. So we get AD plus CB. So these type of reactions occur between ionic compounds. Just for your information, ionic compounds are compounds formed by combination of one anion and one cation. For example, sodium sulfate and barium chloride. If I react sodium sulfate and barium chloride, they are going to exchange their ions. So sodium sulfate, the formula is Na2SO4, and barium chloride, the formula is BaCl2. There are two ions each in both these compounds. So what are the ions in sodium sulfate? We got Na plus and SO4 2 minus, whereas in barium chloride we have got Ba2 plus and Cl minus. Now, when these substances react, they are going to exchange the partners, which means sodium is a positively charged ion. It is going to release, or it is going to split away from sulfate, which is a negatively charged ion, and combine with chlorine, which is a negatively charged ion from barium chloride, and form sodium chloride. Whereas barium, which is a positively charged ion, will combine with sulfate and form BaSO4. So they have exchanged their partners and formed two new compounds, BaSO4 and NaCl, that is barium sulfate and sodium chloride. Another example we can take, reaction between lead nitrate and potassium iodide. Now here also these are ionic compounds made up of ions. We have got lead and nitrate and potassium and iodine. Now when they react, they are going to exchange partners. So lead is going to combine with iodine to form lead iodide, as you can see here, whereas potassium is going to combine with nitrate to form potassium nitrate. So this is also a double displacement reaction. So how do I define double displacement reaction? The reaction in which there is exchange of ions between the reactants. They are called as double displacement reactions. Now in both these double displacement reactions, you can see I have shown something called as precipitate. Now what is a precipitate? A precipitate is an insoluble substance formed during a chemical reaction. So you see powder like substance formed in the solution here. So in this case, the precipitate of barium sulfate is formed in the case of first reaction. In the case of the second reaction, the precipitate of lead iodide is formed. Remember, barium sulfate is a white precipitate, lead iodide is a yellow precipitate. So precipitate is nothing but it is an insoluble substance formed during a reaction. So these reactions can be also known as precipitation reaction. Precipitation reaction. How do I define precipitation reaction? Reactions in which insoluble substance is formed. These are called as precipitation reaction. Is called as oxidation reaction. Oxidation reaction. Now, what is oxidation reaction? The reaction which involves adding oxygen or losing hydrogen. When the reactant, in other words, gains oxygen or loses hydrogen, we'll call such a reaction as oxidation reaction. So here we have an activity. So what happens here is we have taken copper powder in a dish or in a glass bowl, and we'll heat it. When we heat it, you'll see that the brown colored copper will turn black on the surface. Now this is basically a reaction happening with oxygen. What is happening is copper is reacting with oxygen and forming a black colored copper oxide. So when the color changes from brown to black, we should understand that copper has reacted with oxygen and it has formed copper oxide. Of course, this requires heating process. So this is the oxidation reaction because copper is gaining oxygen. Now, suppose I take copper oxide and pass hydrogen gas over copper oxide. Now copper oxide is black in color, remember, and I pass hydrogen gas over copper oxide. The color will change back to brown. Okay, the color will change back to brown, and you will see that the black color disappears and you get copper back. So here in this case, copper is losing oxygen, which is opposite of gaining oxygen that we saw in the first case. So in a reaction, when a reactant loses oxygen or gains hydrogen, we'll call it as reduction reaction. What is reduction reaction? A reaction in which oxygen is lost or hydrogen is gained by any reactant. But if you look very closely, hydrogen is gaining oxygen to form water. So that means hydrogen is getting oxidized. Sorry, I should write it here. Hydrogen is getting oxidized, whereas copper oxide is getting reduced. So in this particular reaction, both the reactions are happening simultaneously. Reduction is happening and oxidation is happening side by side simultaneously. One reactant is getting oxidized and the other reactant is getting reduced. So we call such reactions as redox or oxidation reduction reactions. Again, oxidation is when the reactant gains oxygen and loses hydrogen. Reduction is opposite, when a substance gains hydrogen or loses oxygen. That's called as reduction. But when both reactions happen simultaneously in the same reaction, when one reactant is getting oxidized and the other reactant is getting reduced, we'll call it as redox reaction. Now, this is another example of redox reaction. You can see that we have manganese dioxide and it is reacting with HCl or hydrochloric acid. We get MnCl2, manganese chloride, plus chlorine plus water. Now in this case, manganese dioxide is getting reduced because it is losing oxygen and it is forming manganese chloride. So if a question is asked, what name the substance getting reduced, you'll have to write manganese dioxide. See, the answers here will be on the left hand side of the equation. If the question is asked what is getting reduced, what is getting oxidized, all such answers will be on the left hand side of the equation. What is getting oxidized in this case? HCl is getting oxidized. Now remember, HCl is getting oxidized to chlorine as it is losing hydrogen and forming chlorine. So here we see oxidation with respect to hydrogen. Okay, so HCl is getting reduced. So this is a redox reaction. One reactant is getting oxidized and the other reactant is getting reduced. There is one more concept which we need to understand in these reactions, that is called as oxidizing agent. Oxidizing agent and reducing agent. Oxidizing agent, I'll write it as OA henceforth, and reducing agent, I'll write it as RA for our understanding. Now, what is an oxidizing agent? A substance which oxidizes others by itself getting reduced is called as oxidizing agent. So if you look at this particular reaction that we have taken example of, manganese dioxide is oxidizing other substances and it is itself getting reduced. So in other words, whatever gets reduced can be termed as oxidizing agent. The substance which gets reduced can be termed as oxidizing agent. The definition is, oxidizing agent is the one which oxidizes others by itself getting reduced. Whereas reducing agent is opposite. Reducing agent is the one which reduces others by itself getting oxidized. For example, HCl can be termed as a reducing agent as it is reducing others and itself getting oxidized. So in other words, whatever gets oxidized, it is a reducing agent. I hope you have understood. So again, if you are asked to write, name the oxidizing agent and name the reducing agent, again the answers will be on the left hand side of the equation. Manganese dioxide is the oxidizing agent and HCl is the reducing agent. Last part of this chapter is understanding the effects of chemical reactions in our daily life, at least some of them, starting with first, that is corrosion. Now all of us know what is corrosion. The best and the simplest example of corrosion is rusting of iron, as I have shown here. So what is corrosion? Corrosion happens when metals react with the substances in the surrounding, things like oxygen or acids or moisture in the surroundings, and they form different compounds. Now when these compounds are formed, the quality of the metals actually degrades, or strength of the metal also decreases. So corrosion in most cases is not a good thing to happen. So as I said, one of the best example is rusting. It reacts with moisture and oxygen to form a reddish brown oxide, which is called as rust basically. So rusting is an example of corrosion, remember that. Silver articles turn black if you expose them to atmosphere for a long period of time, because they react with sulfur in air, specifically hydrogen sulfide for example in air, and they form a black colored silver sulfide. So that's another example of corrosion. Or you must have seen copper utensils turning green because they react with mostly carbon dioxide in air and they form a green colored copper carbonate. So all these are examples of corrosion which degrades the strength and quality of the metals. So how do we prevent corrosion? We prevent corrosion by simple methods like painting, greasing, galvanizing, chrome plating. I hope you know what is galvanizing. Please leave a comment if you know what is galvanizing in the comment section. So all these methods are used to prevent corrosion from happening. So this is one example of chemical reactions happening in our daily life. In most cases, as I told you, it is not good for the health of the metal. The second example we need to see is called as rancidity. Rancidity is basically the fats and oils in your oily food or chips. For example, they get oxidized when they are exposed to air. They react with oxygen. So they start foul smelling, their taste changes, and this particular phenomenon is called as rancidity. So you must have observed this a lot with the fatty and oily foods. So you can see here fats and oils undergo auto-oxidation, and they start foul smell and bad smell. They produce something called as butyric acid, which is the reason why they start smelling foul and bad. You don't have to remember this particular acid as such, but remember why they start foul smelling and bad tasting. Now, how do we avoid rancidity? The simple things that we can do is storing things in airtight containers will prolong the life of these fatty and oily substances. Also, commercially we add antioxidants like BHA and BHT. Again, we don't have to remember the names, but antioxidants prevent the oxidation of fats and oils. Also, you can in case of chips, for example, chips packets are flushed with nitrogen gas. You must have seen they are swollen like balloon when you buy them. It's not actually air, they are flushed with nitrogen gas, as nitrogen is an inert gas and it prevents oxidation. Nitrogen doesn't allow oxygen to react with the fats and oils in the chips packet, keeping them fresh for a longer period of time. So these are the two main examples of reactions which happen in our everyday life that you need to remember: corrosion and rancidity. One important method which we have to discuss about how to prevent corrosion is alloying and alloys, basically, which we'll see in another chapter, metals and non-metals. So congratulations for finishing the first chapter. Do subscribe to the channel to get more videos of the other chapters which I'll be uploading soon. Also, if you like the videos, please subscribe to the channel. If you've not seen the part 1 of this chapter, part 1 also has been uploaded. I'll leave a link in the description below. Do check out the part 1 of this chapter also. Thank you so much for watching.